My name is Stephen Casper, and I'll talk a little bit about some work that I did at MIT in the algorithmic alignment group alongside these nice people at the bottom of the slide. Our work is on using some tried and tested image classification tools to better understand how effective diffusion models are at imitating human artists. Our central motivation is to test some approaches for better analyzing legal claims. We're interested in measuring the extent to which diffusion models can copy distinct and potentially protected aspects of artistic expression. Right now, diffusion models are very good at generating art from prompts. This is in part because they're trained on internet scale data, which includes copyrighted work. And this raises a lot of questions about the extent to which these models can learn from and can imitate the copyrighted work of human artists. In other words, we ask how good these models are at plagiarism. Here on this slide is an example of artwork from a real human artist on the left, alongside an attempt by Stable Diffusion to imitate that artist on the right. Actually, just kidding, it's the other way around. But what do we do with claims about copyright violation and damages in a case like this? If an artist says that a diffusion model has learned from their copyrighted work to cheaply imitate them without their permission, thus devaluing that work, how do we test that? For example, should a person determine if an imitation is too similar to an artist's portfolio? This is a common principle in copyright proceedings, but it has challenges. Reasonable people can disagree in marginal cases, and it's difficult to be very consistent with this type of standard alone. So maybe should we determine liability based on whether training data included copyrighted works? This is also common and one of the things that existing litigation focuses on, but it's also challenging because today models are typically the result of multiple training processes, and this makes it hard to fairly determine liability. For example, Stable Diffusion v1 is built off of OpenAI's CLIP model. It could not have learned to imitate specific artist styles if CLIP hadn't already learned to encode that information. So this makes it more difficult to clearly assign reliability and responsibility in a case like this with a standard like this. So in addition to either of these two options alone, we propose using image classification tools to match imitation images back to artists. This is consistent, quantitative, and connected to the capabilities of a model as opposed to just its training data. We emphasize, though, that we're not trying to automate determination of infringement. Instead, we want to demonstrate how some common image classification techniques can help us to better analyze legal and also normative claims. We test this approach with an audit of Stable Diffusion's ability to imitate a set of human digital artists. We started by finding 70 artists with work in the Lion dataset, which is the dataset of images that CLIP and Stable Diffusion are trained on. We wanted ones who might be harmed by digital imitations, so each of these artists publishes or sells their artwork and has more than 100 images in the Lion dataset. So on the left here is one example of a Stable Diffusion imitation from each of these 70 artists. Our first experiment's goal was to reclassify digital artists from these Stable Diffusion imitations. On the right, you can see how we did so. We used a very common technique using contrastive language image pre-trained models, also known as CLIP models. A CLIP system is two models in one. It's an image encoder and a text encoder. And the pair can be used as a classifier by encoding an image and a set of textual labels. Then whichever label's encoding is the most similar to the image's encoding is the assigned label. So for each imitation image, we use this method to classify it among all artists' names plus 3 default labels. Those default labels were artwork, digital artwork, and artwork from the public domain. These default labels can help us more strongly conclude when the model is imitating a specific artist instead of some sort of more generic style. We did this for all 70 artists for 10 imitation images each, resulting in 700 total trials. Out of those 700 instances, 81% of the time, we could successfully re-identify an artist from a Stable Diffusion imitation. This compares to 8.6% for a random name baseline that we tested, and also 1.4% for a random guess baseline. Overall, 69 out of the 70 artists could be re-identified successfully in a plurality of the 10 trials. So from this experiment, we can conclude that artists can be reliably identified from Stable Diffusion's imitations. Next, in a second experiment, we worked to match imitation images to real images from human artists. We again used CLIP to encode images and then compared how similar the encodings of real artist images were to imitations of that artist versus imitations of other artists. Then we used a statistical rank sum test to see how similar the imitations are to an example of the artist's work compared to others. And overall, for 63 out of the 70 artists, the results were statistically significant under a conservative Bonferroni correction. So from this experiment, we can conclude that artists' works can be reliably identified from Stable Diffusion's imitations as well. Overall, we think there are three important takeaways from our experiments. The first is that tried and tested AI classification techniques can help us measure the success of digital imitations of human artists. Second, this can help us to tie questions about copyright liability to the capabilities of a model in a way that's quantitative and consistent. And third, Stable Diffusion is definitively successful at imitating the expression of individual human digital artists. So thanks for listening. Here are some QR codes for the paper and code, plus my email. Please send me a message if you have any questions. And overall, we hope you find this work interesting and useful. Thanks.